Hello everyone, welcome back to my YouTube channel. And we are working on getting started with Linux. This is for some of the folks who are getting started and they are beginners with Linux. I've been recording this for quite some time, got busy with life and haven't been able to up to update it for last about 2 months. But here we are back again on it. And today we'll look into chapter 10, which is on disk and file system management. Um, so the way Linux looks at file system or anything that within Linux you have is it looks at it as a file. Everything inside Linux is a file. Even your keyboard is a file, even your mouse is a file, your screen is a file. So you read from one file, you write to another file. That's how it works. Right? But in this chapter, we're gonna see how our inputs are actually stored in persistent memory, which is hard disk, right? Now we'll look into different kind of partitioning schemes, which is MBR and GPT, right? And we'll also talk about disk and partitions and file systems. What are the file systems, and bit more about that. There is fair amount of CLI. I didn't include GUI. GUI is easy. You can search for GUI utilities very easily. You can find. We'll create ext4 file system and mount it in FSTab. You'll also learn a bit more about network file system, and then we will also talk a bit about some advanced file systems. For example, by default now standard is XFS, then there is BTRFS and all that, right? All right, so let's get started. So at the lowest level that I was talking about, right, when you need to store something, you need to have a hard disk. In Windows, when you or even Mac OS, when you plug in a USB or plug in a, let's say, SSD or hard disk or whatever, right? You plug it in. As soon as you plug it in, something pops up on the screen, or you go to Explorer and you see the new disk and maybe drive EFG something, right? And you are able to browse. So similar thing in Linux. Linux also has something which can do hot mounting, but uh, Linux is more subtle, where it requires you to so-called take an action which is named as mount and unmount. Mount means you are showing the content of the disk in file system hierarchy. So by now you must have understood that everything is under slash, right? Slash is named as root. So inside root, whatever you see is a file, right? But there is a directory called dev. Dev means devices. Okay, this dev is designated for devices. Inside dev, you will see devices which are block devices, character devices. And before I get ahead of myself, I'll start our VM. And uh, for your uh, convenience, I have included my Vagrant file in this repository. So if you go on getting started with Linux and go to static, inside that you'll get this Vagrant file, which talks about what I am booting, which is basically Rocky Linux, and what version I am booting. I'm adding a extra disk to it, and I'm allocating 1024 MB memory, right? So I'm using Vagrant to create a virtual machine, and inside that virtual machine, we are going to work on today's chapter, right? All right, so coming back, how the disks are and how do they work. Let me start my virtual machine. Okay, so it's importing the base. Machine will be up. very quickly. So basically, it downloads this Bento Rocky Linux 9. I already have it downloaded. That's why you see it getting created really fast. Otherwise, if you try to do it yourself, uh, initially it downloads. That downloading might take some time based on the speed of your network. Once you do Vagrant up, it does everything. It creates the VM, but real fun starts when you do vagrant SSH. You are sitting inside the directory where you have vagrant, and you are able to get inside the virtual machine, right? So if I say uname A, you can see I'm sitting inside a local host. It says Linux. It shows me some version, right? If I get out and say uname -a, you can see I was sitting on a MacBook, right? So let me get back in, and let's get started. So I was talking about dev directory. So if I do lsl in dev directory, you can see some files are starting with C. C is a character device. Okay. And I'm not interested in devices starting with C. I'm interested in device starting with SD. This is their name: SDA, SDB, and all that, right? So it starts with B. B is block device. Like, this is your device where you are actually storing the data. This is your hard disk, basically. SDA1. And this is partition 1, partition 2, partition 3. It has 3 partitions, right? Then we have another disk that I was showing you inside this vagrant file, right? So go to static vagrant file, and this 10 GB, it says extra storage, right? So when I booted my machine up, it was showing you that it created a 10 GB disk, right? So let's get back to where we were, and let's continue working on our chapter. Okay, so now we are able to see disks. They are represented as block devices in dev SDA, VDA. Right? You could be SDA is for generally SCSI devices or SATA devices. There could be HDA for the hard disks, right? The spinning platter disks. They are no longer. Uh, I think they are no longer provided in newer either laptops or desktops, but still, if you are in a cloud, you'll mostly see something like SDA or something like VDA, right? uh, Another option would be, if you really want to find, so do /dev and grep line starting with this caret symbol is line starting with BR. So I'm looking for anything that starts with the BR or B itself, right? So that tells me, you can see it color codes the output. These are block devices, and it says it is a disk type device, right? All right. So we are able to figure out these are kind of SATA devices or SCSI devices, right? So I've given some links that would help you in understanding what the disks are, right? Each disk gets mounted. uh, Remember, I was telling, when you attach a USB or a disk to a Windows system, what it does is it provides you with hard disk EFG, some number, right? And you are able to browse. Similarly, in Linux, you are able to mount it, and then you are able to browse it, right? Then next command that I have given here, this is just to list the disks, and two, this greater than two is standard error. uh, so I'm sending standard error to dev null. Why? Because if I don't have these, it'll throw an error, and I didn't want to see that error. That's why I'm doing it. Dev null is another device only. Basically, it's a black hole, right? That's what dev null does. It's a corrector device, and it's a black hole. Anything you send to dev null, it gets destroyed. Yeah. Anyways, basically, I'm sending error to dev null because I don't need to see it on screen, right? That's what I was doing. But otherwise, if I run this command, you can see the output, something similar to what I was showing here, right? So I was doing lsl, instead of yeah. So if I do lsl and line in the beginning, you can see sda. Here is sda 1 2, right, 2 3, then sdb, right. Okay, all right. So now we know hard disk. Let's talk about how do we use hard disks, right? In older times there used to be something called master boot record. So why do we need a master boot record, or why do we need to partition the hard disk? We need to partition the hard disk so that we could use it better. Imagine you buy a place to live, and it doesn't have rooms, it has a huge hall only, right? Doesn't provide you enough utility. To better manage it, what do? You do is you partition the house in kind of different rooms, right? Similar story in hard disk. We want to partition it so that operating system can live in one partition, so that user by mistake doesn't fill it up. And your data can be in another partition, just in case. There is a reason behind doing this, right? Just in case you need to reinstall the operating system, it should not destroy the data, right? Similarly, you want to delete data, but you don't want to impact the operating system, or you are creating too much data, it fills up the hard disk, you don't want it to impact the operating system, right? So those were the kind of basic reasons why we decided to partition hard disks, right? So there are two types of partitioning schemes. One is master boot record partitioning scheme. Basically, it is it stores the partition information in the first sector of the disk, right? So it's supported up to four primary partition, three primary plus one extended, right? So I've given a lot of information here. I'm kind of repeating the same thing, right? There are partitions numbered from 1 to 4. Master boot is maximum, it supports maximum of 14 partitions, right? So this was for the disks that were up to, I think, 2 terabyte, I believe. Yes, yeah. So mbr supported disks up to 2 terabyte only, right? So now look at this. This is one partition, this is second partition because it says primary, this is third partition, and this whole red thing, the red circle, it is a extended partition. This is a fourth partition. But if you create this fourth partition, you cannot use this fourth partition unless you partition it logically. That is how you used to get total 14 partitions. So 11 logical partition and 3 primary partitions, right? So I think I have mentioned it somewhere here that you can, yeah, right, we cannot use extended partition for data storage. So this partition, this whole circle with red, you cannot use it to store data. But if you are able to break it down in logical partitions, then you store data inside those logical partitions, right? So that's the story, a kind of a visual representation to help you in understanding. Now, this was good for the time being, till systems were having smaller hard disks, and we had older kind of BIOS style bootloaders, right? So your system boots up, BIOS starts, and it goes to the first sector of the disk and then starts to boot the operating system, right? That's how it used to work. I scans the entire hard disk, detects the MBR, and load the bootloader program from the disk, right? That's what it used to do. But with cloud, with hard disk kind of getting extended in size, it became clear that we needed something better. That's how GPT came into life. It is globally unique identifier, GUID, and GPT, right? PT is partition table, G stands for GUID. Okay, GU is globally unique, ID is identifier, right? So and it is part of UEFI, Unified Extensible Firmware Interface, right? So when UEFI came into picture, from BIOS, people shifted to UFI, right? Or UEFI. That's when GPT also came into picture. It's part of UEFI, right? And then since MBR supported up to 2 TB only, we were looking for disks that could support larger. It also support up to 128 partitions, right? So I've listed a lot of details about it. You should read through it. And then there were problems with MBR, like 512 byte sector, right? MBR stored partition information bootloader in the first sector of the hard disk, right? So MBR first sector, whereas GPT 512, right? Now you can store information maximum up to 14 partition, 2 TB disk space. I think I need to fix this part. This need to go under MBR. But anyways, to address this issue, GPT uses 4K. So this 512, I mixed it with the GPT. This is limitation of MBR. So first sector, which is 512 byte sector, and 14 partition up to 2 TB of space. That is limitation of MBR. To address this, GPT was created with 4 KB sector that allows GPT to store up to 128 partitions, right? And maximum 18 exabyte of space. Now compare this with 2 TB and here 18 exabyte, right? So that is another thing. Another thing that you see is MVR is non-redundant. Basically, everything is stored in the beginning of those the disk in 512 byte sector. You destroy this, your partition scheme information is lost. So is your file system, right? So it is stored in single place. It's a it could fail, somebody could overwrite, there were problems, right? So that's what, if first sector corrupt, this becomes useless. To solve this, GPT stores a copy of it before and end of the disk for redundancy. So it is a bit harder to kind of cause that corruption, which could happen very easily in MBR, right? So you can see, uh, so that if you have a larger disk, it could still work with this. That's why uh, there is a MBR partition still on a GPT disk. You have GPT header in the beginning of the disk, you have GPT header at the end of the disk, so it is for redundancy stored, right? Then you have partition table, and you could have 128 partitions in it, right? Then similarly, you have partition table backup. Whereas if you talk about this guy, it was 512 bytes. It was stored really in the beginning of the disk, and all the partition table information used to be stored there, right? That loss, everything gets lost. Now, let's see, how do we find if our disk is uh, GPT or MBR partition, right? So let's run this sudo parted and print. If I do grep -I, or if I can do this, right? Partition table, it says GPT, but otherwise also from the output you can see here, right? So instead of A, if I look at cancel, I wanted to see SDB, and it says partition table unknown. Why? Because we never partitioned that disk. SDA, operating system, did that when we built it. SDB, we attached additional disk, but we never had a file system on it, right? How else you could see? There are tools, for example, LSBLK, right? List block, basically. LSBLK means block devices, right? So it shows you SDA3 partitions of it, then it shows you SDB, right? And oh yeah, another thing, you see it says 816. So so SDB, if I do that, you can see 816. This is major number and this is minor number, right? This is your drivers doing it. So files or your storage driver is allocating number 8 within kernel, and this is a instance out of it. That's how it is minor number, right? um, but you can see SDA and SDB there. And where does it get mounted? How does it kind of automate? How do things get mounted in the system? You can see here it says UUID. uh, let's BLK I don't know if I have that command -h BLK hyphen I dev SDA1. Let's see, BLK hyphen K dev SDA1. Yeah, it shows what file systems it can support. And list one label hyphen P hyphen I dev SDA1 sudo, because I'm vagrant. That's why. Okay, so let's do it again. SSH sudo su blkid, and you can see it shows this, right? So this, why I was running those commands, because inside fstab you can see etc fstab. Inside fstab it said uuid and then slash, right? So this uuid is SDA3. So your SDA3 is your root file system or root partition, right? Then you have boot EFI. It has another kind of UUID. Then you have swap, which is, you can see it says none, right? But still there is a UUID created for that also. Then you have details about the partition too. With the help of BLKID you can see them, right? So that's how you identify the disk. Everything that gets mounted gets stored in this file. So you can read more with the fstab 5. So you can say man 5 fstab. I don't have man pages installed on this, but anyways, uh, man hyphen a, uh, it is DNF install fstab. I don't know if it'll do it. Mm, I think I'll cancel it. I'll leave it. Okay, we can see it online, but if you have a good system, you could with the man pages installed, you can look at the fifth man page of it. Right? It shows you the FS or FS tab details. Right. Okay, maybe my network is having some problem. That's why. Okay, all right. So now disk utility, this is a GUI based thing. You could do that if you are using Ubuntu. Similar story, concepts are same. It works same, exactly same on Ubuntu and Red Hat. So I'm using Rocky Linux. Rocky is a flavor of kind of Red Hat. That's why my commands might look a little different, but I'm using, for example, DNF. I was trying to use. But in Ubuntu you will use apt. That's the only difference, right? But next is inspecting from command line. So lsblk-f, basically it is showing you file systems along with their labels, right? What type of file system is created, vfat, this, xfs, and where it is mounted. Everything is kind of explained here, right, with this command. Dfh is showing the mounted file system. Like for example, SDA3 is mounted on slash, SDA1 is mounted on boot EFI. All right, then these are kind of mounted on the fly, tempfs and all that. Ignore them. Anything starting with slash is what is more important. Now, we looked at this one. It says it is GPT partition, right? Then next, how do you create file system, right? So let's run one command at a time. So we did lsblk. SDK has three partitions. I don't want to touch it because my operating system runs from this, right? SDB has no partition. So let's check out. So fdisk is a utility that you can use to partition hard disk. -l is to list. That's why it didn't do anything. But if I run without L, it gives me a prompt like this, right? Then it says, what do you want to do? I can say M for help. It gives me long list, right? And then you can see it says N new single disk partition, P for partition, W to write, right? I can do that, or I can do G, create a new label. I can do that, but let's do p is to print, right? So new partition, it's a primary partition, partition number one, and it says what is the first sector. And now you can specify size in mbs and gbs. Let's say 1g, hold on, let's say plus 1g. So when I say plus 1g, this is my bad. So it is meaning starting from the very first sector till the last sector. So it was asking for the last sector, right? So I had to do plus. So plus 1g. So now it is creating a 1 GB size partition, right? If I say p, you can see it created a disk level type DOS, but you can see it here. We can create another partition. If I say 2, right? So what do you see here? It says 2 of 4. So it is creating second partition, then third partition. Total 4 it'll let me create. If I create all 4 as primary, I'm done. I cannot create fifth one, right? What I could do instead is create 3 primary and fourth as extended. Then I can go all the way to 11 logical partitions, right? So let's say default, then I can do another plus 1g, hold on, 2g. Do I even have the, oh sorry, it is first sector. I, oh, 1g, right? So, and if I say p, I got 2 partitions, right? So if I say d, it asks me you want which partition you want to delete. By default it is deleting the second. It says second partition deleted, right? So n primary, so default is second, first sector, let's say 2 GB partition, right? This is second partition. First partition was 1 GB, second is 2 GB. Let's say third partition, then 3 GB. Oh sorry, enter plus 3 GB. Now what I'm trying to show you is, what if I create 4 primary partitions, right? So how much we have used? 3 plus 2, 5, 6 GB, right? N primary, enter, and let's say this is 4 GB, value out of range, last sector, let's say plus 1 GB, and I have 4 partitions. If I say n, it says you cannot create because maximum supported partitions are 4 only, right? So I need to delete one partition, deleted p n, and I say e is extended first sector, then plus 1g, right? Then n. Now it doesn't ask me whether it is primary or secondary because it is creating a extended logical partition, right? Plus 1g. Okay, p, I had to, it's my bad that I created fourth partition of 1g. So what happened? I should have used whatever was remaining, 3 plus 2, 5, 6, 6, about 4 GB I should have used, or 3 GB remaining of 10 GB in extended partition, right? So let's say delete p, delete p, uh, let's say delete, right? So first partition we have n, I can say extended partition, partition number 2, I gave it full whatever the size was, right? Now what do you see? You have first partition and second is extended. Say n, now it is logical partition, right? Everything after this is logical. So 1G, this is already, it says it is partition 5, right? Why? Because total 4 could be inside primary, that's how, right? And 1G, and you can see it did 1 2 5 6, right? Okay, so if I need to write, I can say w is partition table altered and syncing the disk. And if I say fdisk hyphen l, now it shows it is DOS type and it shows the kind of partitions, right? So this is one way of doing it. Then you can create a file system on the disk, right? So um, what does file system do to the disk? It is basically, imagine a book where you have index in the beginning. It is creating index. So when you store a file, some of the file's metadata gets stored in the master boot record. The master boot record knows what sector has which file stored and what size of what is the size of the file, who is the owner, this, that, all that information gets stored in the kind of metadata of the file system, right? That's what happened. Your hard disk get partitioned into, let's say, tables, and in the beginning some of the information is stored in this metadata area, right? That's what creating partitioning does. Similar to when you insert a disk in Windows, sometimes it says it is not partitioned. Can I format the disk? You format it, then only you are able to store files in it, right? So formatting does nothing but creating the file system, wiping out existing file system if there is. If so, this command is dangerous. This command, this one we did, it is also dangerous. So be careful. Don't run it on your personal laptop or something, right? Do it in a virtual machine where you are safe. So if I say lsblk-f, now you can see it shows like this. It shows SDB has file system, B256 doesn't have anything, right? Earlier it was showing SDB only. Now let's mount it. We can create a directory and then, oh, sorry, uh, my light just got turned off. I need to turn on the light. Okay, all right. So now if we mount it, can you can see what happens. MNT data, it says 1% used and it says STB1, right? So in this I have kind of given some examples. So if I say touch, right, and if I say sudo ls, you can see if hello.txt is created, right? Now unmount is command similar to eject in Windows, right? You could, like, it has a, in the status bar it says remove device safely. That is what unmount does. Basically it, um, all the dirty blocks are committed to the disk, and disk is, access to the disk is blocked so that you could easily remove it, right? That is what it does. So if now again I try to do lsl on this directory, you will not see this hello.txt. Why? Because I unmounted it, right? So now what do we do? Again, we could mount it again, and if we do lsl, you can see disk is back, right? So dfhl, if I say, you can see here h is human readable, l is local. I, you know, if you have, it's, I'm kind of used to it, that's why I do hl. L is for local. If you have nfs, you don't want to make calls because it need to show the size, right? That's why I do dhl. uh, Again, this is how it shows. Fs tab, if you want, when system reboots, you want this mnt data to automatically be available. Every time you reboot the system, you want it to be available, right? So how do you do it? You make an entry in this file, fs tab, as I was saying, there are man pages. Even fs tab is also uh, kind of it tells you what are the fields available inside it, right? uh, some of the accessing file system, it doesn't have that, but generally it does. But the idea is this is what need to be mounted. So you could mount it either using UUIDs, or you could mount a slash dev SDB1. Why not use SDB1? Why use UUID? Because these names, they do change when you reboot. It depends on your UDEV rules. There is a system called UDEV. It could persistently give you the exact same name, but at the same time, if you don't have UW rules, there is a good possibility that system will figure out, and it might change from let's say you had 10 disks. There is no guarantee that SDB1 will be the same disk if you reboot, and you if you don't have good UW rules, right? So solution was using UUID, and that's why we were running this command, which we lsblk-f, so that you can see the UUID of it, right? So you'll say UUID equal to this, and the second field is, for example, here it says slash, and here it says boot EFI. Second field will be mnt data. That is the directory, or that is the mount point. Mount point directory must exist before you mount anything. Another thing, rookie mistake when people start to kind of use Linux, they get stuck in this. You can see it says busy. Why? Because I'm sitting inside that directory. If I say pwd, you can see it's an mnt data, right? You are sitting on a branch that you are trying to cut. Solution is you get out of that, or if there is a process using it, use lsof. Then lsof is list open files, lsof, and give the mnt data, right? Figure out what process is using, see if you could kill it. Okay, coming back, file system, what need to be mounted? It could be UUID or dev, whatever the name is, right? Slash dev sda1. Mount point, where it need to be mounted, what type of file system it is. For example, here it says it is xfs file system. This is from fstab file, it says xfs, right? Then options, by default generally we use defaults unless you want to kind of modify. Again, you can learn a lot about it with the help of man pages, fifth man page for fstab, right? And then last two is you want to dump, and this is for fsck, whether it should, when system reboots, should it run a file system consistency check or not? You could control this as well. Right, dump is for backups. uh, People don't know about these two. Mostly during interviews, sometimes people ask, right, to trick, what is the last field, right? So you could basically disable file system checks with this. Anyways, um, so when you made an entry inside FSTab, one option is you can say mount and name of the mount point, right? So let's do this. Let's make a entry in FSTab, vi etc FSTab. Okay, another lesson. Whenever you modify a system file, okay, take a backup and label it with for example, 1 19 20 26, right? So what did I do? I did preserve permissions and everything. I took a backup just in case I mess up with this. I have a file, right, to go back to. So it's a best practice, always take backup, right? So we did that. Let's copy paste something. I don't want to kind of write everything from scratch. Hold on, I want to exit out. Let's copy paste. Okay, so I did y and p. That's how I was able to kind of print it, and I kept pressing X. That's how I was able to delete a single line, right? So now MNT data, right? So just to make sure it looks nice, that's why I'm doing it. If we see now, we don't have that MNT data mounted, but now if I say MNT data, if I have everything missing, hold on, it says wrong. Did I create, what file system did we create on it? LSBLK. Oh, we created ext4. See, and I mentioned it is XFS, right? That's the problem. So I fix it, and now I say mount MNT data. Command ran, something happened, right? DFH MNT data. If I say you mount MNT data, it's gone. You can see it says SDA3 instead of SDB1, right? And also it says slash, right? Now let's mount it again. Mount, and you can see it says data SDB1. What I did by doing this is created a persistent entry so that if system reboots, uh, it'll still get mounted. Now you keep seeing this message hint, you need fstab refresh, system still uses old version. You need to run this command. It is required in newer systems because system uses something called unit files. Systemctl hyphen t is target mount, um, list unit files, I think. Yeah, you can see it says 12 units, and it talks about EFI, talks about different file systems, it talks about root, right? Now let's see if we do systemctl daemon reload, and if we do this from 12 it went to 14, so it generated some entry somewhere. This is what it did, MNT data, and you can see it was missing in this output, right? So how do I see more? Systemctl status MNT data mount, and you can see from where it came, and it is what was mounted, where it was mounted, and all that, right? um, that's about it. That's the kind of list of things you do with the file system. Again, you could do mount hyphen a. A is mounting everything that you have entered inside fs tab. This is if you have, let's say, hundreds of file system in fs tab listed and you want to mount all of them, you'll do this. If you want to mount a very specific one, do something like this: mount space mnt slash data, right? The way I was showing you. Now we can reboot the machine and see if it is still there. And next is NFS file system. So again, I don't want to cover too much on NFS, but it is something similar. The file system which doesn't exist inside your own system. And it's not the hard disk. Imagine you have a NAS device, or a service provider is giving you storage, right? You could mount it using NFS network file system. So how you do is your server name, then colon, and then what they have exported for you, or the path they have exported for you, where you want to mount it, what is the file system type, which is NFS. Defaults, again, it goes 00 because you don't want to dump it, you don't want to uh, FSCK it, right? So this is very simple example of a NFS entry in your FS tab. You could control options. For example, NFS version 4. Older versions are sometimes not supported, so you might have to write something like this, right? Read size, write size. This is controls the buffer size, because now your file system is coming from NFS basically through network, through your network interface card. You want to control read write buffers. Hard and soft. Basically, it defines how your file system should behave. Soft means if you have mounted it soft and your command is getting stuck, you did df and command is stuck, you can do control C, and basically you are able to interrupt or stop the command that was trying to call it. Hard means it'll be stuck till you get a response. Suppose you have a network outage and you are not able to access the network file system, it will cause problems if you have it hard. But sometimes it is required to have it in hard mode. You don't want file system mounted as soft, right? Again, then timeout, there are options. Basically, you could write all the options separated by comma like this. So I would say go read FSTab. I know this has been a very long chapter. We already covered this, daemon reload and all that. How does it get created? For example, here it says where did it write? I don't know if it did it. Oh, we could basically, what I'm trying to say is you could create a unit file like this, and you don't need to make an entry in FSTag. This is another way of basically mounting file system. So one, you are mounting file system in the beginning the way we were doing, right? That is all temporary. Why temporary? Because if system gets rebooted, your file system will not come back. Uh, what we did by adding this entry here, we made it persistent. Now if we reboot, this file system will still be there, right? So generally in servers you do it this way, right? So that was one way of making it persistent, by making an entry in fstab. Another way of making persistent is something like this. You create a unit file yourself. Here we can see it created a unit file for itself, and like it did on the fly, that's why it says generated. But if you create this, it'll possibly will say static or you created, right? uh, so this is also kind of way of persistently mounting the file system. Now, we checked all this, we looked into this. There are more file systems available to in Linux than what you just saw. So if I say cat proc file systems, you can see all these types are supported. No dev means we don't have drivers loaded for this. But these are all kind of supported file systems. All you need to do is do mode probe, and you'll be able to possibly load those file systems and use them. Again, Linux is extensible. You could install another module. All these are basically modules, right? If I say ls mod and grep for ext4, you can see ext4 is loaded, right? ext3, I think it comes from the 4 itself, I believe. ext2, oh, we are not using it, that's why. So mod info ext3, yes. So ext2, so you can see these modules are fs. This is the alias. It is coming from ext4, but it is listed as ext3 and 2 as well, right? Again, what I was saying is these are modules. You can see here, this is the location from where it is coming, right? So everything is ext4. Even ext3 is a extension of ext4. As here ext2 also, because I looked for ext2, is an extension of ext4. That is how Linux knows what file system it supports. So cat proc file systems, that's where we go and see. uh, if we have a module loaded, we can see about, learn more about it with the ls mod and grep for that module xfs, right? Otherwise we can say mod info xfs, and you can see it shows from where xfs was loaded in the kernel. Anyways, that's all I had. Linux is vast. This was the beginning only. I did include some of the items that you could do for hands-on to learn more about it. um, more advanced file systems, for example, BTRFS is also a thing. And there is Linux volume manager also, right? So those things I have not covered. I think I have a chapter planned for that. Possibly uh, volume. Yeah, so chapter 17 will talk about volume manager and all, right? I'll be uploading the video. This link will get updated. It says TBD, but I'll make sure it gets updated. With that, I'll stop recording. Thank you, everyone. If you have any questions, comments, please comment on YouTube or on my give me a pull request on GitHub or comment on my LinkedIn. Thank you and good luck. Happy learning.